You know, when you think about artificial intelligence, you think of just massive computation, mind-bendingly complex stuff, right? So you'd probably guess the language powering it all would be the fastest, most complicated thing out there. But it's not. It's Python. And how we got here, well, that's a fascinating story.
It's a total paradox, and it trips up a lot of programmers. How on earth did this language, one that's often criticized for being slow, become the undisputed king of AI? Well, the answer has almost nothing to do with raw machine speed, and everything to do with a kind of radical idea that really changed programming for good.
And that radical idea? It was simplicity. Seriously. Python's whole journey to the top started with one core belief: focus on the human developer's productivity, not the machine's efficiency.
So, let's rewind to the late 80s. A programmer named Guido van Rossum decided he wanted to build a language that was powerful, sure, but also super intuitive. Then in 1991, he did something huge. He released it as open source. That move planted the seeds for the community we see today. And this whole philosophy eventually got written down in 1999, in a document every Pythonista knows, the Zen of Python.
And one of the core ideas, maybe the core idea, is right there: readability counts. Now, this wasn't some happy accident. It was a deliberate choice. The goal was to make code that reads almost like plain English. Why? Because it makes it way easier to share, to debug, and to build on top of, which, as you can imagine, is absolutely critical for the kind of complex, team-based work that AI research demands.
And this really gets to the heart of the matter. See, older languages were built back when computer time was super expensive, so everything was optimized for the machine. But Python just flipped that script completely. Guido van Rossum had this amazing insight. As computers got cheaper and faster, the real bottleneck wasn't the hardware anymore. The real expense was developer time. Python was built from the ground up to save that time. So, where did this people-first approach really find its footing? Well, it wasn't in some Silicon Valley startup. It was in university labs and research centers. This is where Python quietly built the scientific foundation that pretty much all of modern AI now stands on.
The secret sauce, really, was a handful of absolutely game-changing libraries. Tools like NumPy, SciPy, and Pandas gave scientists these incredibly powerful tools for heavy-duty math and data analysis. But, and this is the crucial part, they didn't have to become expert software engineers to use them. For the scientific community, this was a massive, massive breakthrough.
So here's the magic trick. These libraries basically solved Python's so-called slowness problem. What they did was wrap super fast, low-level code, stuff written in C or Fortran, inside a simple, friendly Python wrapper. So you got all the raw speed you needed for the heavy lifting, but with the amazing ease of use that Python offers. It was literally the best of both worlds.
Okay, so you've got this super strong scientific foundation in place. The community is growing. The stage was perfectly set for an absolute explosion. Python was about to become the launchpad for the entire AI and data science revolution. And the result was this incredible, sprawling ecosystem. Suddenly, tools for every single part of the AI puzzle started popping up, all in Python. For machine learning, you got giants like TensorFlow and PyTorch. For big data, PySpark. They all chose Python, building on that scientific bedrock and creating this powerful, virtuous cycle. The more tools, the more users. The more users, the more tools.
So, what does this all mean for the people actually doing the work? Well, the benefits are huge. You can prototype new ideas way faster. You write a lot less code to get things done. You can write it on your Mac and run it on a Linux server, no problem. And maybe most importantly, if you ever get stuck, you have one of the biggest, most active communities in the world ready to help you out.
So, after this amazing journey from a simple scripting language to a global AI powerhouse, let's just pull it all together and recap the core reasons why it's still on top.
Look, no language is perfect, right? And yes, Python can be slower at runtime and use more memory. But here is the key takeaway. For AI development, those drawbacks don't matter as much. Why? Because in AI, the big race isn't about raw execution speed. It's about the speed of experimentation. How fast can you test a new idea? And for that, Python is unbeatable. So it really all boils down to these three pillars. It all started with a philosophy that put people first. That philosophy allowed a powerful, layered ecosystem of tools to grow on top of it. And the whole thing is held up by a massive, collaborative, open-source community that just keeps pushing things forward.
You know, there's this great quote from a longtime Python core developer, Brett Cannon, that just nails it.
The simple, clean language might be what gets you in the door, but it's that amazing, supportive community that makes people stay and build the future with it.
And that kind of leaves us with one big question for the future. As AI models get even crazier, more complex, more demanding, will Python's core strength, its simplicity, continue to be its greatest asset, or could it become its biggest liability? Honestly, the answer to that is probably going to define the next chapter of AI.